So in this video I want to look at an example of how a grapher program could be used as a simulation software. So this is Desmos, and it is a completely free graphing calculator app. You can get the app through Google Chrome. There's a mobile phone app, or you can just go to desmos.com/calculator, and this is what you have. So let me show you kind of what you can do with it. So students can just start looking at what the graph looks like and graph it. Any graphing calculator could do that. This is obviously maybe a little bit more easy to see for students because we can choose different colors. We can make it dotted or solid, all sorts of things. Now, instead of just having a simple line that we can graph, we can also include variables. For example, let's say we want to explore slope of a line. And so we can add a slider. So instead of putting a number in for the slope, I put m for slope. And so it puts it at a default of 1. So right now the slope is 1. And maybe I want to focus on just the slope, so I'll get rid of the y-intercept. So what it does is I can push play and it's going to change the slope from -10 to 10 and back again. And so we can see what's happening to the slope as I increase it up to 10. Or I can go down to -10. So we can see that it changed when it went to a negative slope. I can speed it up, or I can slow it down. I can pause it. I can even change the range. So let's say I want to go and look at only positive slopes. So maybe I'll start at 0.1. And maybe I'll go up to something ridiculously high like 100. So I can either show this to students as a demonstration, or if they have their own computers, I can instruct them on how to do this and they can play with it themselves and they can kind of take ownership over it and explore it on their own. So this could be like an introductory activity. And then, but the applications are pretty much endless. So let me show you another example from my pre-calculus class that is on let's see, we're going to be looking at soon compositions of trig functions. And so you can also hide or show various trig functions as you do it. So in this particular one, I set f of x to be sine of x and g of x equal to be cosine of x. So then I can multiply them. And I didn't have to write sine of x times cosine of x. All I had to do was write f of x times g of x, and the program took what f of x was and g of x was and multiplied them. So then we can compare them to the sine and the cosine, and we will look at, okay, what's happening? Why is this happening? We can look at like the intercepts. The intercepts of the cosine function are at 0 are also x-intercepts of the new function of f of x times g of x. We could talk about why. And why are, the zeros or the x-intercepts of the sine function involved. So we can compare things very easily looking at that. We can look at what happens, we can take that one away and look at what happens when we add the functions, or when we subtract the functions, or when we subtract them the other way. Let's look at another case. Here's another one from my pre-calculus class where we were looking at sinusoids, or graphs of sines that were changed in certain ways using transformations. And so we can talk about amplitude and how amplitude is determined by the absolute value of this a. So we make a variable and we can push play and see what happens when a changes. What happens when a is negative? So I see this not only as a way of simulating the graphs, but this program has the possibility of being a problem-solving application as well. Given the right setup, you can have students try and prove why things are happening the way they are after they've discovered them. So it has sort of an overlapping application as a program. And then we can look at what does the B do? What does the C do? And we can pause them and start them however much we want and try and look at the patterns of what's happening. This is just not something that's ever going to be possible without technology. This isn't something I can do by hand. And that's the power of this program for mathematics, to give students an insight that they would have not been able to have without the technology that's this program has provided us.